Okay, we've got the integral of the square root of 1 plus x squared over x dx. Alright, and Aaron, you looked at this, and what were your first thoughts?
So that x equals tangent theta?
Okay, so let's let x be equal to tangent of theta. This seems like a very valid idea because we have the square root of a squared plus x squared where our a value is 1. And the 1 plus x squared, we're thinking of 1 plus tangent squared theta equals secant squared theta. So choosing x to be tangent theta makes a lot of sense. Okay, so we do this, and then we do a few things over here. Let's see, we can replace 1 plus x squared. Well, 1 plus x squared will be 1 plus tangent squared theta, which is equal to secant squared theta. And so the square root of secant squared is just secant. So our entire numerator is replaced with secant of theta. And our denominator, that's an x, so we'll replace that with tangent theta. Alright, we're not quite done. We still have that dx at the end, so I know that x is equal to tangent theta, so dx is going to be secant squared theta, d theta. So over here I've got myself a secant squared theta, d theta. Alright, so if I look here to cancel, things don't cancel nicely, and I'm left with the integral of secant cubed theta over tangent theta d theta. Alright, and so did you get this far?
Yeah, that's where I really got stuck. And I tried it 100 different ways.
Alright, well, anybody have any thoughts on this? So let's see. Secant squared theta is tangent squared theta plus 1. Okay, we can try that. So this is our scratch work over here on the side. So let's see if we can come up with anything useful. Secant cubed theta over tangent theta is the same as secant squared theta times secant theta over tangent theta, which is 1 plus tangent squared theta times secant theta over tangent theta. Okay. We could split it up a little more. We could have secant of theta over tangent theta plus tangent squared theta, secant theta over tangent theta. Okay, so one of these tangents will cancel over here.
Secant is equal to 1 over cosecant. Or cosine? Sorry.
So
1 over.
secant is 1 over cosine.
So your tangent is secant over, or sine over cosine. If you multiply by the reciprocal, end up with cosecant there.
Okay, so
Secant plus secant.
So this one here we can simplify into cosecant theta. And this one over here, we're left with tangent theta, secant theta.
go from the 1 plus tangent squared theta to the,
to this line here.
yeah,
So the first thing I did is I distributed the secant theta through the top,
okay,
so that I have secant of theta plus
yeah.
tangent squared theta secant theta,
Mhm.
all
And then
divided by
Oh, okay.
tangent theta, and then I split it up. Okay, so this seems like a reasonable possibility. We have cosecant theta plus tangent theta secant theta. And this is what we're thinking we might want to plug in over here. So we'd have the integral of cosecant theta plus tangent theta secant theta d theta. Yeah, we've got a plus sign in there, so we can split that up. So we've got the integral of cosecant theta d theta plus the integral of tangent theta secant theta d theta. Let's analyze the second one first. What is the antiderivative of tangent theta secant theta? Yeah, this is secant. And so we've got something plus secant theta. It's the integral of cosecant theta d theta. Now, on this one, I'm going to punt a little bit. We specifically derived the integral of secant theta. The integral of cosecant theta is extremely similar. So let's look this one up. So antiderivative of cosecant theta, if you check that out somewhere in that same section or in the front, what do you end up with?
Ln of cosecant theta minus cotangent theta.
Do I have a second on that?
I've got ln sin x over cosine, well, theta, sorry, sin theta over cosine theta plus 1.
Okay, which could be possibly the same. What is our, this is pretty similar to the one when we had secant in terms of antiderivative of secant gave us ln of secant theta plus tangent theta. So this one's really similar. So let's go ahead and go with this one. So we've got that plus secant theta plus c. Jeff?
You go back,
Yes?
right there, you've got above that secant over tangent, right?
Yes.
Secant is 1 over cosine, right?
Yes.
And tangent is sine over cosine, right?
Right, so you have 1 over cosine
So-
divided by
Oh, okay.
sine
All right.
theta,
Okay,
cosine
great,
theta, and so.
okay.
Yeah, so I definitely
Alright.
skipped a lot of
Okay.
steps on the
Okay,
scratch
yeah,
here,
okay,
for sure.
I got it.
Okay, so this one, if you need the integral of cosecant theta, I will give you that one on the test. All right, so now we've got to this point. Are there any questions up till there? Are we done?
No.
No, we got
Nope.
bust
Still
out
got
the
it.
triangle.
That's right, we've still got to bust out a triangle here. So what did we do? We said that x was equal to tangent of theta. And so I have no number. Normally I have a number in front of the tangent, so I can really think of this as tangent of theta is equal to x over 1. And so this is my opposite over my adjacent side on my triangle. My opposite side is x. My adjacent side is 1. And that tells me that my hypotenuse, if I do the Pythagorean theorem, is going to be square root of x squared plus 1. Or 1 plus x squared. And that's good. I can have a happy feeling at this point because that expression that I have written right here exactly matches with this form that we started with. Okay, and that's going to be a good sign that you're on the right track. Okay, so now we've got to fill in our information. We've got the natural log of, okay, cosecant of theta. Cosecant theta is hypotenuse over adjacent. Is that right?
How come we had x equals tangent theta?
So substitution is very.
Okay, so first question, cosecant is reciprocal of which trig function?
Sine?
Of sine, yeah, okay, so this should be hypotenuse over opposite. Alright, Dennis, what was your question?
I was surprised x equals tangent theta, but it was from the
Yeah,
beginning.
that is our crucial substitution at the very, very beginning. Alright, so hypotenuse is square root of x squared plus 1. Our opposite side is x. So we can fill in that part. We have natural log of square root of x squared plus 1 over x minus cotangent. Remember that cotangent of theta is adjacent over no.
1 over x.
You guys, all of my trig in my head right now is all turned upside down, so please help me. Cotangent of theta. All right, thank you. Adjacent over over opposite, not hypot. So cotangent of theta is adjacent over opposite. So our adjacent side is 1 and our opposite side is x. So we have minus 1 over x and the absolute value plus secant. Secant of theta, that's 1 over cosine. Yes? Okay, 1 over cosine, which means that we have hypotenuse over adjacent. So our hypotenuse is square root of x squared plus 1, and our adjacent side is 1. So we have plus the square root of x squared plus 1, and then a plus c on the end. You should not expect more than 1 trig substitution on this exam. But you should expect 1. Alright, Erin, does that answer your question?
Yeah.
Okay, cool. So the tricky part in this came when we had to analyze secant cubed theta over tangent theta, and one way to do that is to rewrite secant squared as 1 plus tangent squared and mess around with it.
Yeah.
So will you award partial credit if you get stuck in that step right there?
Sure, absolutely. I mean, if you have made a good choice for your substitution, if you've chosen your x to be a tangent theta, and you have gotten to the point where you've turned your entire integral into thetas, and now you're struggling with how am I going to analyze this integral, you're certainly partway along the right track. So absolutely, I do award partial credits. Okay. Other questions about this example? Other practice problem questions? On anything? Nick?
You go over 13 from 6.6.
6.6, number 13.